Yeah, I'm gonna welcome everyone. Hi, folks. We are going to just wait a minute or two and let a couple more people filter in before we actually start the presentation. But thank you all for joining us this morning or evening, depending on where you are. You can feel free to introduce yourself in the chat. You should see a chat tab off to the side. You're welcome to say hi. I'm going to see if this works. I'm in Portland. We're going to have a couple of quick little quizzes, fun quizzes for you as we go today, just to see who all is joining us and where you're coming from. It is really nice to be with you. So for those of you who haven't had the pleasure of meeting me before, or I haven't had the pleasure of meeting you, I'm Hannah Neuschwander. I am our Communications and Strategy Director at World Coffee Research. I'm going to be joined this morning by who is our scientific and research director. There's Tanya over here on the, oops, there we go. Okay, trying to make my little clicky button work. There's Tanya. Tanya is joining us from Canada, outside of Ottawa, and also my colleague Amelia Umania, who is our Nursery Development Program Manager, who is joining us from Costa Rica. Yeah, wonderful. Thank you for introducing yourselves. As we go this morning, I'll just do a couple of light housekeeping here. Please feel free to put any questions that you have into the Q&A tab. There's a chat tab and a Q&A tab. So use the Q&A tab for your questions. We will have plenty of time at the end for a little bit of Q&A. So please don't hold back. We love to hear what your questions are. Some of them we may be able to answer in the chat, and others we will have time to answer in the Q&A session. We are really delighted to have you with us today to talk a little bit about the progress of our F1 hybrid trials that have been going since 2015. But before we dive all the way in, I just want to pause and thank all of you. This is a call is a members only call. We are here today with you, our member companies. There are over 200 member companies of World Coffee Research now in 30 countries around the world. And it's really because of you and the support that you offer our organization that we are able to do any of this work. So thank you for your commitment to ensuring the future of coffee, and especially those of you that have been around for the last 7 years that this project has been going. Again, it wouldn't exist if it weren't for your support. So thank you. I'm just going to say a couple of words about what we do at WCR and how this connects to our F1 hybrid trials, and then I'm going to pass it off to my colleagues to really dive down on the progress of this program and where we are now. As most of you know, we at WCR enable the global coffee industry to invest in coffee agricultural science. Through our work, we are connecting the existing infrastructure for coffee research, most of which happens in producing countries through national coffee research programs, but connecting it to you all, roasters and industry, and making sure that as new innovations come into being, new varieties, new approaches for farming and production agriculture and coffee, that the roaster and industry side is connected to that and has feedback into it. As a small example, many of you on the call have participated in cupping some of the F1 hybrid varieties that we're going to be talking about today and offering quality feedback. And that's really, really critical as we are developing new varieties that are going to be going out into farmer fields over the next few decades. We want to make sure that they are working for you all, that they fit into your product portfolios, that they are what consumers want to be drinking in their cups. And so we see ourselves really as a bridge between these two critical parts of our industry. As most of you know, the majority of our work focuses on coffee varieties, historically on Arabica, but increasingly also on Robusta. Why do we do that? We do that because variety innovation is a very high leverage, highly efficient way of tackling challenges that we have as an industry. One of the things that is really cool about variety development is that you can address multiple problems at the same time. So for example, if you were to develop a new variety that had higher yields, which is of course important for not only for farmer income, right? More coffee from the same amount of land is really important for just pound for pound, dollar for dollar. But it is also a way that you can, at a large scale, help avoid land use conversion, which is the largest contributor of agriculture to climate change. So the more coffee you're able to produce on existing land, the fewer, for example, trees in neighboring forests that you might need to cut down. So you may have a higher yielding coffee that is already getting you important benefits in terms of income and land use management and climate emissions that is, for example, tolerant to diseases and pests, which is going to reduce the loss that farmers have and is also going to potentially reduce the amount of chemicals they may need to spray. If that same variety is also able to be grown effectively in multiple environments, whether it's a little hotter or drier or cooler, you have a climate resilient variety that is going to help farmers ensure that they have continued production even as the weather is changing. And of course, if it also tastes great, you have the potential to capture quality premiums. So you can fit all of that into a single package in a new improved variety. And that is really exciting and really urgently needed for the coffee sector. So that's why we focus on variety innovation. You can do this at scale. You can deploy new varieties over entire countries or entire landscapes at once if you have them and you have the resources to deploy them. And so this is the sort of long-term investment that coffee is going to need in order to be able to keep up with the challenges that are coming with climate change. We know, as I just said, that it delivers impact at scale and again, can be done globally and collaboratively. So it's a very efficient investment for an organization like WCR to focus on. One of the things we don't focus on really is agronomy. And I'm going to pause and just say a quick word about this because it is a question that we get very often. Why don't we focus more on agronomy? We know that good agricultural practices are really, really critical for increasing yields for farmers and for increasing cup quality as well. And that's all very, very true. However, it is something that tends to need to be done locally. There are different kind of cultural and management practices in different places. And so optimizing them can depend very heavily on local approaches to growing coffee and also what's available locally in terms of products that a farmer might use, fertilizers, et cetera. And maybe most importantly, there are already a fairly large number of institutions and organizations that handle that. So whether it's extension agents from a National Coffee Institute or suppliers or organizations like TechnoServe, there are a lot of folks that are focusing on improving coffee agronomy, which is critical intervention to help improve yields and productivity. But there's a ceiling for that. And once we hit that ceiling and optimize agronomy, the only way to continue to improve productivity is through better varieties matched with those better products and practices. So the problem with varieties is that the timelines are long because coffee is a tree crop. So even if you optimize every part of the breeding process, you're still looking at about 12 to 15 years for a new variety release, up to 30 years, depending on the approach that you're taking. So if we don't start now, as these other institutions that are really working hard to optimize agronomy continue to do their work, we need to be putting new varieties into the pipeline so that they're available for farmers at the right time. So we try to work at multiple timescales, but when we're talking about variety development, we're really talking about that kind of decade plus timeline. Variety development also greatly benefits from global coordination, as I said before, and that is a role that we are very well positioned to work in. So with all of that preamble about the importance of varieties and how this all works, I am going to turn it over to my colleague, Dr. Humphrey, to talk to us a little bit about the F1 hybrid program and where we are now. Over to you, Tanya.
Thanks, Hannah. Thanks for that good introduction. So I'm going to drill down a bit now to talk more specifically about our F1 hybrids project. And you may have heard about this in the past because it's been running for a few years now, and we're at a critical transition. So we'll go through some of that. So before I get into it, I need to explain what even are we talking about? What is an F1 hybrid? So quite simply, it's a hybrid between two parent varieties. So you take two different varieties that have different traits, different positive characteristics that you might be looking for, like disease resistance or yield or, crop architecture or all kinds of things that you might be interested in. But the point is they're different from each other and they have a set of complementary different traits. And what you do is you cross those two varieties. You take the pollen from one and cross it to the female flowers on the other. And when you collect the seed from that, what you have is your F1 hybrid. So F1 simply means first generation. It's the first generation cross from the hybrid of two parental lines. And what happens when you do that is you get the best of both worlds. You get quality traits from both parents coming together in one individual. And as well, you very often get this phenomenon known as hybrid vigor, because you have diverse genetics coming together in new combinations. The plant can very often have a degree of growth and vigor and yield that is much higher than either parent. So this is a kind of a common breeding strategy that is used in many different agricultural crops. So it's something that's used very commonly in corn or maize, as well as vegetable crops such as tomato. And it's something we can also do in coffee. Oops, click, there we go. So what makes them different from regular varieties? So really, it's about that generation timeline. So an F1 hybrid is that first generation. So compared to a conventional variety, what you're doing breeding a conventional variety is selecting for the quality traits that you want through multiple generations. And as you go through the generations and select for what you're looking for, what you're doing is you're fixing the genetics and you're creating lines that are essentially genetically stable. But of course, that takes a long time. That has in coffee, it has a timeline of around 30 years. So it's a very long-term endeavor. And certainly that is something that we've started at WCR with our breeding network. So we are taking this strategy. And ultimately, it results in a variety that's fixed, it's stable, and it's cheap and easy to reproduce from seed. So it is a very highly valued strategy. F1 hybrids, on the other hand, have some different qualities. So it's a much shorter timeline because you only have that one generation. But because you're selecting at that stage, what you have is a diverse genetic material that is essentially genetically unstable. It's not fixed because you haven't gone through multiple generations of selection. And so what that means is if you want to reproduce that hybrid vigor and all those quality traits that you see, you need to propagate that material vegetatively. So take cuttings or somatic embryogenesis, or use some kind of propagation that doesn't involve seed, because as soon as you produce seed, then you have segregation and those positive traits start to segregate out because it's genetically unstable. And so if you want that high-performing material, you stay at that F1 generation. Often, because it is a high performer, it does require more fertilizer and other inputs. So it's expensive to produce by propagation. It can be expensive to grow in the field for the farmer. So it's kind of a bunch of trouble. Why would you want to do it? The short answer is it's a shortcut way that you can achieve really high performance by combining traits, getting that hybrid vigor. So it's not unheard of to get 30 or even 40% higher yield in an F1 hybrid. And so that alone makes this a very attractive strategy, despite the fact it's kind of complicated and difficult to manage. So you can see both of these strategies are equally valid in the right circumstances, and at WCR we're pursuing both. We're talking today about our F1 hybrids, but we're also doing conventional variety development and breeding. So ultimately we'll end up with a portfolio of options for farmers. Now, I've talked a little bit about how F1 hybrids are complicated because of they're genetically unstable. And so what this means for farmers is saving seed is actually a huge risk. So because the desirable traits segregate out, the plants are not uniform. So this is illustrated quite nicely in this picture at the top here. It's not coffee. It's more like your genetics textbook example. But you can see on the top left there are high-performing F1 hybrids. You can see they're healthy, vigorous plants, very uniform in how they look. If you were to take the seed from those plants and plant them the next generation, the block on the right is what you see. And so you can see very clearly how the material is segregating. You don't get that uniform high performance. You get some individuals which are sickly and weak and have various other undesirable traits. So you're not getting a uniform material in the same way that you do with a conventional variety. And so for farmers who are in the habit, the practice of saving seed and planting new material from the seed they've collected elsewhere, these are not good varieties to use. You do not want to be putting F1 hybrids out into a production environment like that, because it creates the risk for the farmer. They're not going to see that consistent performance that they might be expecting, and they'll get this highly variable production. So of course the bottom picture is actual how that looks in real coffee plants, the sort of segregation that you might see. So you do need to manage this risk, and typically that's done through either restricting the release to make sure that hybrids are only going out to farmers who can handle it, and into countries and supply chains where that is effectively managed to avoid the risk of saving seed. And as well, you can mitigate it through training and education of farmers so they do understand what these varieties, how they work. As well, you need to have a source of propagative material. So if you can't propagate these through seed, you need to have some other mechanism to do micro cuttings, tissue culture, somatic embryogenesis, or some entity in the country that are producing these varieties for farmers who wish to plant new trees. So you need to ensure that piece is addressed before you just put the varieties out. Otherwise, you will probably get seed saving as a common practice. So in our hybrids, this is what the project timeline has looked like. So you can see that it started back in 2015. So this is one of the longer running projects at WCR, and that was through a collaboration through some different organizations, including CIRAD and Cartier in Costa Rica. So at that time, there were 43 different crosses that were made between different hybrid varieties, with the idea it's this big diversity experiment. So those crosses were done at Cartier in Costa Rica, and field trials were planted in 2017 from that material. And since then, we've been evaluating that material at different sites, looking at how does it perform in terms of its production in the field, and also in terms of cup quality. So this timeline shows the point at which we're at today. We're kind of you can't see my arrow here, but we're at this transition point between the field trials that we've done so far, which have pretty much on kind of a small scale evaluation. And now we've got some good performers. We've got some data that we're confident that these look promising. And so what we need to do is transition to the next phase of evaluation, where we essentially are going to look at these top performers on a much larger scale. So we need to evaluate them under a larger scale conditions that more closely resemble commercial agriculture. So what we did over the past few years, we had trial sites at 4 different locations in El Salvador, Costa Rica, and Rwanda. And the idea here is to evaluate the material in a few different sites, different altitudes, different environmental conditions, to really get a sense of how they perform across a range of different conditions. And so we have the data that's still coming in from those sites right now. Here is a nice picture showing this is our site at El Salvador, our farm Flor Amarilla, where we have all the hybrids, and we've been evaluating them for the past 4 years. And when we planted the trials, a key part of it is the randomized design. So I talked about there was 43 different crosses. Now what we do is we randomize all of those in the planting scheme, which you can see here, Julio's holding it up. All of the hybrids are randomized and planted in this random way to try and minimize some of the variation that you might get even within a site. And then each of those individual trees is data is collected on each of them individually, and then we're able to pull that and really look at the performance and evaluate all the hybrids compared to each other in this plot design. When we look at them, we're looking at two things really. We're looking at their performance in the field. So that's like we look at their overall growth and vigor, but importantly, because of its importance around the world as the #1 disease and threat to coffee is coffee leaf rust. This is one of the key things that we're evaluating. So we look at how they do in the field. We evaluate for leaf rust. We look at yields. We know that's really of utmost importance to farmers everywhere. So yield is a critical thing that we need to look at. And the way we do that is by collecting all the coffee, all the cherry off every individual tree. So we're collecting the yield of every tree, and we're compiling all of that data so we can really understand the performance of the different genetic combinations. Then we also look at cup quality. And I know this is something that many of you may be interested in, perhaps you had the chance to participate in. We bagged up a lot of these samples and sent them out around the world for people to try. So we had, over the past 3 years, we've had 71 cuppers, 50 companies, 10 countries doing these cupping evaluations to taste the hybrids. Sorry, I've got this little thing popped up here. To taste the hybrids and evaluate their performance and give us the quality scores, which we can then analyze and use as our part of our performance data. So that was the other piece of it. And so that brings us to the final 4. The point that I talked about, we're in this transition between these small-scale randomized trials where now we want to move a smaller subset of the top performers into this next stage evaluation, what we're calling the pre-commercial trials, which is really a bit scaled up from what we've done so far. So these are the hybrids that we're talking about, and you can see they have these really creative names, WCR 19, 29, 30, and 9. So they're just numbers. But all of these selections, they have some things in common. One of their parents was a Sachemore line, which means it was a variety that is both high yielding and rust resistant. And then the other parent was a high cup quality geisha line. And so those were all the crosses that resulted in these top performing hybrids. And these are the 4 that are moving forward to the next phase. So I'll just show you some of the data. I've just got a bit of a few selections here to show you so you can see how this looks. So what we've done is compared them consistently to Marsellesa, which is a conventional variety. It's a fixed line, but it is a known high performer. And so a lot of people are familiar with this variety, and it certainly offers a good comparison and a target. So we need to show that we're performing in that realm of performance to know that these are worth moving forward with. And so what you can see here, this chart here shows performance in terms of yield. For each of the hybrids down the left there, you can see the different hybrid lines compared to Marsellesa, as well as another line, Iapar 59. And this shows the performance at 4 different sites. So this is actually 4 different yields data plots that you can see. The bottom left is Rwanda, which doesn't have the full selection of varieties yet because this site was only planted, I think, two 2 or 3 years ago. So it's a little later coming along. So the full set of data is not available yet. But you can see at the other sites, 2 sites in Costa Rica and 1 in El Salvador on the bottom right there, you can see the performance of all 4 of the WCR hybrids looks really good compared to both Iapar 59 and Marsellesa. And if you average this all out, what it's showing is all 4 of these hybrids average around 25 to 30% higher yields than Marsellesa. And you can't see in this particular chart, but from other trials that we're running side by side to some of these, we are able to compare the yields to another hybrid that people may be familiar with, H1 Centro Americano. We have the data to compare yields between these 2, and what we're seeing is our hybrids are very comparable to H1 Centro Americano. So it is showing these are high performing and are comparable to other hybrids that are on the market. What we do see here, though, is the performance does differ across the sites. So you can see that quite clearly in these charts. And this kind of highlights the need to continue to evaluate this material. So it's not ready yet to recommend to farmers. There's still variability and uncertainty in the performance. It's looking good, but what we need to do is evaluate at scale to get us some data that will really give us the confidence to make those recommendations to farmers who may want to be putting some new varieties in their fields. Rust resistance is another piece of the data. So this little score chart on the left here, it shows how we score rust resistance, and it's basically a 5-point scale depending on how much rust spots you see on the leaf. And so every plant is scored in this way. And what you can see here, instead of showing all 4 of the charts, I'm just showing you one site, because what we saw with the rust data was essentially all the varieties are equivalent, and all of the hybrids are equivalent, and they are very much the same performance as the Marsellesa and other lines that are also shown to be rust resistant. So essentially, all of our hybrids are in the same way as Marsellesa and Iapar 59 are showing really strong rust resistance. And I'm just showing this one plot here from El Salvador because this was the only one where we saw some degree of variability. But if you look at the actual scores here, this is really not that significant. Our rust scores are still very low, between 1 and 1.5. So it's really essentially very, very minor rust spots on the leaves. So we're really pleased with this result. And frankly, it's not entirely unexpected, given that we specifically chose rust-resistant parental lines. So this is a really good result, and this is certainly what farmers want to see. Then the cupping data, this is the results compiled from the most recent cupping that was done at the Boston SCA event earlier this year. And so when our hybrids were cupped and scored compared to the other lines, other varieties here, we saw good, strong performance in terms of cup quality. And 3 of them actually averaged a cupping score of around 84 points, which is a really good score. And again, that's something we would like to see. So this is all the data that's gone into the selection of these top 4. And so we're pretty confident that it shows they're high yielding, they're rust resistant, and they have good cup quality. And so these are the 4 that we're moving forward with for the next stage evaluation. And so that brings me here to the pre-commercial trial discussion. This is the next phase. And so I'll hand it over to Amelia, who's going to be managing this process.
Thank you. Good day, everyone. So I'll talk to you a little bit about this next phase that my colleagues were discussing, the pre-commercial trials. And as both Hannah and Dr. Humphrey were discussing, the process of developing a new variety and getting it out to farmers is a very long one, even for F1 hybrids, which is a shortcut, and it's much longer for non-hybrids. It's still a very long process, and it's still a process that offers no guarantees at the end, because you need to get to the very end to make sure that your material provides something that is useful for the industry or for growers. Okay, there we go. So the way this works is that typically a large number of crossers are made, and then they are evaluated for at least 6 years to see if any of them are promising. And we need 6 years because it takes roughly 3 for the coffee tree to produce its first production harvest, and then another 3 years of data of harvest to verify the performance and the yield data and make sure that the material offers something useful and new and relevant to the coffee world. So in most cases, only a few finalists will be selected for advancement based on that performance that Dr. Humphrey just talked about. So once the finalist candidates are selected, they are typically advanced to a larger pre-commercial trials, which you can see in the middle of your screen right now, which is the phase that we are entering right now. So this year in fall, we will be seeking partners to host this next phase, the pre-commercial hybrid trials for the 4 finalists. And if any suitable partners are identified, then partners will install the 6-year trials for final evaluation and potentially then commercial release eventually. And this process has already started for us. In preparation for these, we engaged Katia to propagate 12,000 plants, hybrid trees that are being propagated via somatic embryogenesis, and these baby plants are currently in development. And if any interested partners are identified and trials can proceed, and if the F1 hybrid candidates perform well in these pre-commercial trials, then partners could decide to commercialize the trees eventually. And if they do, then these hybrids would join a small handful of F1 hybrid varieties that have only very recently, up until the last few years, become available to farmers. So at this point, Hannah?
Hi, thank you, Amelia. Yeah, so we are going to have time for plenty of questions. If you all have questions about F1 hybrids in general, about the particular work that we've done with them, these final 4 varieties, and what's going to happen next, we welcome you to enter those questions into the chat box. I'm going to get us started with a couple of questions as we wait for yours to come in, with a question that I get all the time as someone who engages with a lot of roasters and other folks in the industry. Tanya, I'm going to send this one over to you. Can you clarify, are F1 hybrids genetically modified?
Yeah, good question, Hannah. This does come up quite a bit. So basically, the short answer is no. No, this is not genetic modification. This is a version of conventional breeding that has been done for millennia when you take the pollen from one plant and you cross it to the pollen on another. And so this is not genetic modification, how people think of it. This is conventional, regular, old-fashioned breeding, and it's just we can use modern tools like genomics and sequencing to get a better look into the DNA, but the breeding itself is really quite straightforward, not genetic modification.
And I'll make a little plug there. If you scroll back up through the chat, my colleague Maeve posted a link to a video that shows our breeding and technical manager, Jorge Berni, making crosses on our research farm in El Salvador, Finca Flora Maria. And it actually shows you like how you take the paintbrush and you get the pollen and you do the whole thing. It shows what the whole process looks like. It's about a 2-minute video. So if anybody's curious what hybrid crossing looks like in the field, you can check that out. Okay, here, on to some of our questions from our attendees. Emily from Pete's was asking, did all of the original F1 hybrids, there were 43 crosses, folks who participated in some of the cuppings probably didn't taste all 43 of them. It was more like a subset of 30. Did they all have the same parents as the ones that ended up in the finalist pool? Or did they just, and second question, did the 4 finalists just happen to have a rust-resistant parent and a kind of geisha line type parent?
Yeah, so I think the answer is no. So the 43 crosses were a whole variety of different parents. And so the whole plan originally was much broader, looking at a much more diverse set of genetics. But as we start to look at this material with a view to not just understanding the genetics, but moving them out to actual commercial production, then we have to be a little more constrained in which ones we move forward, because we don't want to put something that's just interesting out on a commercial farm. We want to make sure that it's a strong performer. So rust resistance was a must-have. And so that was part of the narrowing down process, is which are the subset of parents that have strong rust resistance. We know quality is another thing, and that's why the focus on the geisha lines as well. And so there's kind of a process of multi-phases to narrowing it down based on what's going to work, the background genetics, as well as what the performance that we're seeing in the field and through the quality assessments.
Awesome. Question from Philippe from JDE. Did Centro Americano H1, was Centro Americano H1 part of the research as a reference point? Same question on Star Maya. Just a quick background for folks on that question. Centro Americano and Star Maya are both F1 hybrid varieties that were developed about 20 years ago now, and commercially have been released in a couple of different countries, in particular in Central America. So they were not part of our breeding program. They came from another breeding program led by CIRAD and Promo Cafe and Ecom. Those varieties are commercially available for farmers now. So there are some existing hybrids that are on the market that farmers can use. And so they're a great reference point for understanding, how do these varieties maybe perform against the ones that are commercially already available for farmers.
Yeah, so I can just speak to that. The answer on the H1 Centro Americano was not part of the original hybrids design. And so it's not incorporated into that randomized plot design that I showed you, because it wasn't part of the original experiment. But what we have is other trials side by side. So if those of you who are familiar with WCR's work may have heard of our IMLVT trials. So this is our international multi-location variety trials, where we've basically taken a whole lot of different commercial varieties and put them in sites all around the world as a large scale assessment of variety performance across all of these different environments. And because we are running those trials in a few cases, so at Flor Amarilla and in Rwanda, we have those sites side by side with our F1s. And so we are able to make an almost direct comparison between the yields of H1 Centro Americano and the yields of our hybrids, even though they're not exactly in the same trial. So we have the data, it's just not all in one package.
But I would also like to offer that for our next phase in the pre-commercial trials, the check is going to be H1 Centroamericano, now that we want to compare hybrids against already commercially available hybrids.
Mm-hmm.
Yeah, good point.
Awesome. Okay, so another question from our folks, from Audrey. Are there hypotheses for the variable yield performance across the trial sites? Tanya, I think this is referring to the slide that you showed that there were differences in, even though you had the same genetics planted in these 4 sites, they didn't always perform the same.
Yeah. So I wouldn't say there's specific hypotheses around this, but this is frankly fairly typical for what you would see between different varieties at different sites. And this is precisely why we do evaluations at multiple sites, because each of the sites differs in terms of its environmental conditions. So different soil types, altitude, rainfall, pest and disease pressures, all of those things differ between sites, and all of them impact yield in significant ways. And so, you can plan bigger trials and experiments to try and dissect all of that out to understand what's happening. But we don't generally do that. We're just looking at overall yield. So it's likely to be multiple factors. And again, it highlights the need for why you need to do continued evaluation at multiple sites and over multiple years, because you don't just get variation between sites. You get variation between years, particularly rainfall and temperature and those types of things. So, you really do need more data, multiple sites, multiple years to really be confident in the performance. So that just highlights that.
Question for maybe Amelia, you could take part of this, and Tanya, if you want to jump in on it as well. Just Amelia, you're very familiar with all the sites where these coffees have been grown in Central America. You visited all of them and worked very closely with the farmers that are tending to them. Leah Jiamin is asking how the coffee cherries are processed. Are they all processed the same way? So when roasters are tasting them, are they tasting, apples and apples? And do we have any research on how processing impacts cup quality?
Yeah, that's a very interesting question, especially because in my country, the different types of processing has been a point of interest for many growers in the past few years. This site in particular were all managed the same way because we wanted to maintain a certain certainty that if any differences occur was because of the fruit itself and not because of the process. So all of it was processed, washed, so regular standard process for coffee. So we just take each of the cherries. We have a small mill that they will be processed on. They all have the same treatment. It's all washed coffee. And then cuppers get the same exact type of process. So whatever difference they taste is because of the genetic of the hybrid and not necessarily because there are other processes. Mm-hmm. It would be interesting to continue the process and say, well, what happens if we do this in honey? What happens if we do this in natural? But for now, because we wanted a very standardized process just to measure the performance of the genetic material, it was very important for it to be standardized.
Mm-hmm. And, it's very possible that of the 4 finalists that we've narrowed, not all of them will end up being commercially released. And so, yes, you may not want to invest a lot of money doing elaborate trials on processing if you don't know for sure if those varieties will end up being available for farmers. So that would be kind of like a step 2, 3, or 4 for folks. So,
like I said, there's no guarantees in this process. So we may get to the end of the line and realize that there's nothing really super special about these hybrids. So we will have to do the whole process to make sure that there's enough data to talk about the performance and the yield and the characteristics of this hybrid. So we haven't finished that yet. But certainly different processes in the mill are super interesting, and I would like to have enough fruit to do all of the different processes. But for now, we didn't have that.
Yeah, I mean, there was one picture that we showed in here. I'll see if I can find it again. That shows kind of how these first stage trials look. Oh, here, I'll pull it up here. So this is a map of our trial site in El Salvador, and basically we have about 10 trees of each cross. So you have lots of crosses, but very few trees per cross, which means you don't have a ton of coffee to work with in terms of testing, unique varieties and stuff. So you're like just hoping you have enough, for you all to be able to taste, let alone to do different kinds of processing. Okay. Another question, this might, maybe Amelia, you could start us off since I know you've got a lot of experience working with hybrids in the field. Can we talk a little bit about how hybrids need to be managed on the farm? Tanya, you mentioned that often there's a need for more fertilizer with hybrids. Is this something that will be taken into account as you move into the pre-commercial trials? And just anything that you can comment on about that aspect of hybrids?
Yeah, so we haven't, until now that we're starting the process, we haven't really tested this for finalists in a large way. We're just starting that process. Typically, hybrid varieties based on others that are commercially available do require are more demanding in nutrition than other varieties, and that's related to the yield that they have and the productivity that they have. So the plant is producing more cherries, so it's needing more elements to make sure that they can produce those cherries. And it's also but not only that, but it's also the way that the coffee plant is, metabolism works. So if it's shaded, if it's in full sun, if it's in a good soil, if it's in a bad soil, if there's drainage issues, all of these variables of the coffee ecosystem affect how the plant reacts. And normally, when you have high performers and you're not providing the environment for them to express that potential, it would just make them less productive than they could be. So because we're trying to explore what is the actual potential for productivity, then it is better to have a management of the farm that it's the top-notch nutrition and the best shade arrangement and all of that management of the farm. It comes into play to make sure that we can express the potential that we're looking for. Same goes for diseases and things that might go around your farm that are very related to management. And frankly, that is one of the risks of the hybrids, that if they are like Dr. Humphrey was explaining, they're not for all of the farmers and they're not for everyone, but that might be for some and for some conditions. And that's our way to make sure that we can provide options quickly, is to make sure that there are hybrids out there that can fill up those gaps in the meantime.
Yeah, if I could just add to that, I think it's important to emphasize that the productivity is probably the single most important factor. For farmers, no matter what crop they're producing, productivity is big. They're a big concern, and even though hybrids might take a bit of extra care and a bit of extra inputs in terms of fertilizers, the point is the productivity will make that worth it. That's the hope, and that's why hybrids are used, because they're highly productive. Even though they cost more, they take more inputs, the productivity makes all of that worth it. So they can be a great strategy.
Yeah, and just to say, productivity, the sort of definition of productivity is getting more out per input in. So, high productivity doesn't just mean you have high yield, it's that you have more going out than you're putting in. So there's a trade-off there. I mean, there's not a trade-off there. Another question about cupping and cup scores is total SCA score, so how many points on a 100-point scale, the only way that you all evaluated quality to pick the short list of winners, or were there other aspects that were taken into account?
So I think, Hannah, you're probably the best one to answer this. Yeah, I'll come back to you.
Yeah, I might be the best because I helped to run our cupping trials. So for those of you who participated in the cupping trials, you had this big long form that had not just total SCA score, but also asked for input on, what particular flavors and aroma attributes there were. And then whether there was another question that had to do with whether or not this coffee fit into your product portfolio. Like, is it a coffee that you could use as roasters in designing the product offerings that you have for your consumers? So cup quality was the most heavily weighted thing that we looked at. Just overall, it is the industry standard way of looking at quality, the SCA score. And so we did lean on that. But that market fit, what's the word we use? Kind of demand question, like, does this coffee work for you? We also looked at that. What we found is that there was a very high correlation between overall SCA cup score and that question. And so when coffees had a high cup score, they also had high marks on, yes, this is a coffee that we could use. The things like flavor and aroma attributes, we didn't use that for narrowing, but it is very interesting for us to have that information and to see, are there certain flavors or aromas or other sensory attributes that seem to be helping drive those scores up. And we did do some analysis on that. It's really interesting. It's also not super surprising. It's things like sweet, fruit, the presence of these basically pleasant flavor attributes, chocolate was another one, would drive the score up, and more negative attributes that are fairly familiar with folks would pull the score down. The one that was really interesting was floral. It was very divisive. So some cuppers really liked floral, and if that was present in a coffee, it would pull the score up, and for others, it would pull the score down. So that was the one where we really saw the most difference. But those factors weren't used for narrowing. They were just used for knowledge gaining. And as we see, if these any of these 4 candidates end up being able to move forward into commercialization, that is the kind of information that would be really helpful for talking with farmers and roasters about, what is it that these coffees bring to the table. So let's see. You guys have great questions. We were chatting before this talk to say, well, I hope we get some questions. Indeed, we did. Did you guys look? This is going back to the question about inputs and fertilizer. Have we evaluated yet in this first stage of trials that we had whether any of the specific hybrids have higher or lower needs for fertilizer? Or is that something that would come later?
So I can take that. Do you want, Amelia? I think so far, similar to what Amelia described before about the processing of the coffee. When you do a trial, you have limited amounts to work with. You have to standardize things and do it in a consistent way, because that's how research is done. You try and reduce the number of variables so you can really understand the differences in the genetics itself. And so the question about fertilizers and nutrient inputs is an important one, and that's something that should be addressed during the next stage. So as we move out to pre-commercial trials, this is where we start to we want to emulate commercial production conditions, so we want to do it at scale. But what we can also do, if you remember the slide Amelia showed about this accelerated timeline, is in parallel to these larger scale trials, what we can do is agronomy trials in parallel. And so this is where you can design specific experiments to look at different nutrient applications and really start to dissect out which hybrids perform best under which nutrient regimes, and you get the best combination, like Hannah talked about, of variety with production practices, because ultimately the whole thing is a package in the end.
So one more question, I think, related to the issue of the risk of deploying hybrids. So if you had a farmer that was really excited and interested in growing hybrids, is that enough? Or are there kinds of, the question, the way it was phrased was, are there ethical approvals that are required, or how would that work? How do you help screen for that risk?
Yeah, so that's a good question, and something that we need to work through with whoever our partner is going forward to the next stage. And as these move forward to commercialization, it's something that we'll be working through. And one of the important considerations is which countries are we talking about? Because it's not just individual farmers that we need to think about, but the systems and the socioeconomic factors in play in the countries in which the varieties are released. And so part of that will be sort of country level decisions. Are we willing to release a variety in this country? Because not every country is at the same stage in terms of their variety management systems, the education levels of farmers, and just the ability to see these things and through and manage them effectively. So that will be part of the discussion. And unfortunately, it does mean that not everyone's going to be able to access them. We need to manage the risk, and part of doing that is making sure it's a fairly limited release. We can't just put them out to anyone who's interested, because we've seen in the past, other variety introductions in the past have gone that way, where they're not necessarily managed properly, and they get not out of control. That sounds too dramatic, but basically, yeah, we need to make sure it's managed, and there's a lot of factors to consider. So we will be going through that. One thing we did do is we commissioned a study on this to get some, expert opinions about different countries and the understanding of hybrids and how they're managed. And so we do have some assessments that are done to give us some preliminary guidance around which countries and which places are the most likely for the release to be happening. And that's where, you know, if you look at our RFP documents, we are choosing to focus first in Latin America. Because they are the most ready, I would say. Latin American countries are often, there are hybrids already out there and they have the systems in place to manage them. So that's our first point of focus. But that's not to say there wouldn't be other countries later. We certainly, if we see great benefits from these, we would certainly we would want to see them accessed by as many farmers as possible. Ultimately, in the end.
And I'd like to add that this is something that is particularly important for hybrids, but it's not unique to hybrids. I would say every variety that goes out there, plants don't come with an instruction book. So farmers and coffee growers everywhere, if you give them certain material, there is a certain level of technical assistance and access to this assessment, continuous walking together with the farmers to make sure that you're giving them the car, but also the keys to make sure that they can drive them. And the reason that this happens a lot is because, well, most coffee farmers have been cultivating the same one or two varieties all of their life. So if you change something about it, there might be some aspects of the genetics or the materials that are going to react differently to what the farmer is doing. So that is true for hybrids, and that's also true for any other variety that you put out there in the system. And it's part of making sure that you release the new product, but also it is user friendly. And part of it being user friendly is that these communities of growers have access to that. I don't know what the word in English is. Like, someone who can walk with them through the process and make sure that they can answer all of the questions and, make the most of the product.
And so that's, part of what we'll be looking for through this process of seeking partners for the next stage is really looking for partners that have that capacity to be providing extra support and knowledge for a possible commercial release. There's a great question. I think this might be our last question, looking at the time, about climate resilience from Philippe. So with these 4 finalists, or with other hybrids in general that we've observed through, for example, the International Multi-Location Variety Trial, do you see some that are especially good in challenging climate conditions, whether that's like warmer or drought, water stress? So how do you think about this question of whether a hybrid's going to be a good performer, not just today, but in 20 years when climates are going to be very different?
Mm-hmm. That is a good question, and I think it's one we continue to ask. And as we get our data in from these large-scale IMLVT trials, I think it's perhaps something more relevant to that than specifically the F1 hybrids. But we are definitely interested in the performance across multiple environments, and that's how the IMLVT trial was designed, because we are testing the same set of material across all of these different environments. And so it's quite likely that what we have, for example, the trial that we have running in Kenya may be an environment that closely resembles what Peru will look like in 30 years. So we have data from today in those environmental conditions that we can draw some correlations and make some recommendations, because we've done this on a global scale, and we have access to test all of these different environments for all of these varieties. So it definitely is something that's kind of embedded within the experimental design of these trials. And as the data is coming through and we're getting more and more performance data, we can really start to tease this out. And yes, there are varieties that perform better across different types of environments. So that's one of the key goals.
Yeah, and just adding onto that. So, one benefit of having a global network of trials like we do through our international multi-location variety trial is that we have a huge variation of environments, which then mimic potentially the variation that you would see over the years of the future. Is sort of what, just restating what Tanya just said. So there's no way to know for sure what the climate in Peru is going to be like in 20 years. But if we put plants today in a whole bunch of different environments, we're much more likely to be able to capture some of the potential future variability. And what we're looking for is plants that perform well across a lot of different environments. So we're not generally right now typically looking for a plant that is super, super good only in one narrow set of environments, but one that is doing well. It is stable in its performance across a lot of different environments. That is a good predictor of stability through, or climate resilience in general. So the F1s that we have today, the 4 trial sites that Tanya showed that graph, it is 4 trial sites. It's 4, different locations, but they're all in Central America. So you're not getting a huge amount of variability. As we expand the trials, we'll capture more variability. In the international multi-location variety trial, where we have some of those existing commercially available hybrids, Centro Americano and Mundo Maya, we're seeing how they perform in a lot of different environments. And in general, we're seeing that they perform pretty well across a lot of different environments, including ones that are very different from where they were developed in Central America. So that's, really great question. Okay, we did it. We made it to the end of the hour. Thank you all so much for joining us for this conversation. Your questions were amazing. Your participation and support through the cuppings and all of the financial contributions that you all make to WCR to keep this work going are so appreciated. If you have more questions, you can feel free to reach out to us. info@worldcoffeeresearch.org is a great place to reach us. The expression of interest application for the pre-commercial trials is in the chat and also available now on our website. So if you think that you all might be interested in that, please check it out and get in touch with us. And otherwise, we just look forward to our next opportunity to talk with you about our work. Everybody have a great rest of your Tuesday. We'll see you then.